Hey guys, welcome back. So today is day 3 for absolute value equations. Now, just to recall, yesterday we were solving absolute values that were in word problems. Today we're going to be creating and solving absolute values from word problems. So let's go ahead and write down that objective. All right, now if you look over here, number 1 and 2 are already worked out for you. They are actually the same exact problems that you did yesterday. So the reason I have them up is because I wanted you guys to look and I wanted to see if you noticed what they had in common, okay? Now, if you look, we have two numbers in this word problem, 57 and 5, all right? We have two numbers in this word problem, 25 and 2. And those are the numbers that are actually in the equations over here, all right? Now, 57 and 25 are called the goal because that is what we're aiming for. The 5 and the 2, those are what we call the more or less factors because that's like the tolerance level, okay? So if you look at the equations, notice that the goal is inside the absolute value and it's also being subtracted. So that's what we're going to write down in this little box over here. The goal is subtracted and in the absolute value. All right, and then you notice that the 5 and the 2 are set equal to the absolute value. So that's the other thing that I want you to write down. The absolute value is equal to the more or less factor. All right, now if you need to press pause to write those down, go ahead. Otherwise, I'm going to the next slide. All right, so here are the 3 steps that you need to take when you are creating the absolute value equation from the word problem. So step 1 is to subtract the goal from a variable. All right, so say that the variable was x. You would be subtracting the goal from x. So that's where we have x minus g. Now, with this difference, we can go to step 2. Step 2 is to put the difference in the absolute value symbols. So here's my absolute values around the difference. Okay. Step 3 is to set the absolute value equal to the more or less factor. All right, so here's my absolute value. Now it's equal to f, which is the more or less factor. This is the whole setup, okay? Now go ahead and write that down. Now for number 3, we need a couple of things in there to actually do the problem. So go ahead and put these numbers in there. All right, I'm going to read it and then we can do this one together. So it says the recommended class size for a successful and cost-efficient high school classroom is 29 students. If the classroom is 3 students more or less than the recommended class size, it is still believed to be successful and cost efficient. What is the highest amount of students in the classroom that the classroom should have? What is the lowest amount of students that the classroom should have? All right, so now we're going to go ahead and set up the equation. So again, we need to first locate the goal. And in this case, the goal is 29 students. So we're going to take x and subtract 29. Because that's the variable minus the goal. All right, step 2 is to put absolute values around this. All right, so there's my absolute values. And then step 3 is to set this equal to the more or less factor. Now the more or less factor is 3, so we're going to set this equal to 3. Now this is just the setup, and you will get points for just setting it up. All right, now we're going to go ahead and solve it to see how many students we can have in the class. All right, so what you need to do is, since the absolute value is already isolated, you can split it up. So you have what's inside the absolute value is equal to the negative. What's inside the absolute value is equal to the positive. We're going to solve each of these, and in each of these you have to add 29. In this case, we have x equals 26. In this case, we have x equals 32. Okay? Now, what does this actually mean? Well, this means that the minimum and the maximum are, the minimum is 26 students, and the maximum are 32 students, okay? So that's us first creating and then solving, all right? Now I'm gonna let you guys try a couple on your own. Let's go ahead and go to the next slide. All right, guys, so here's number 4. So we have 24 and $3.25. You need to put that in there to be able to do the problem. So let me read this for you so that you guys can try this problem on your own. It says, when going to the movies, you should bring $24 to have enough for the ticket, food, arcade games, and a drink. A person who brings $3.25, more or less than the recommended amount, should also be able to enjoy the trip to the movie theater. What is the most a person should bring to the movie theater? What is the least that a person should bring to the movie theater? All right, go ahead and set this up and then solve it. All right, so here's the setup. Again, we have to take x and subtract the goal, so that's x minus 24. Step 2 is to put absolute values around it. And step 3 is to set it equal to the more or less factor, which is a 3.25. All right, the absolute value is by itself, so we can go ahead and split them. So we have x minus 24 equals negative 3.25, or x minus 24 equals 3.25, positive and negative, okay? Now in both of them, you're gonna have to add 24 to both sides. For the first one, you're gonna get x equals $20.75. For the second one, you're gonna get $27.25. So the actual answer would be, the minimum money to bring would be $20.75. The maximum money to bring would be $27.25. Okay? All right, let's go to the next slide, number 5. If you need to press pause, go ahead. All right, guys, so here's number 5. Now what's missing in number 5 is the number 183 and the number 8.5. Now you guys can go ahead and read this carefully, set up the equation, solve it, and identify the maximum and minimum. Go ahead and do that right now. Alright, so in this problem it says the ideal weight to be in the heavyweight division in boxing is 183 pounds. You are still eligible to participate in the heavyweight division if you are 8.5 pounds more or less than the ideal weight. What is the most someone can weigh to be eligible? What is the least someone can weigh to be eligible? So we're going to go ahead and again take the variable x and subtract the ideal weight, which in this case which is the goal, 183. We're going to put absolute values around them, and then we're going to set this equal to the more or less factor, which is 8.5. Okay, absolute value symbol is by itself, so we can split this up. Either x minus 183 equals negative 8.5, or it equals positive 8.5. Okay, now in both of these you're going to have to add 183 to both sides. Okay, in the first one you're going to get x equals 174.5. In the second one, when you add it, you wind up getting 191.5. Alright, now you put an or and circle it, that's the answer. But the real answer is that we have a minimum and a maximum of 174.5 being the minimum and 191.5 being the maximum. Okay? Alright guys, here's the last problem, number 6. Now what's missing in number 6 is the number 50,000 and the number 7,250. Go ahead and do this one on your own, read it carefully, set up the equation and solve it. Okay, so let me read this really quick before I actually start doing the problem. It says a company made a new design on a telescope. On the box it says that you can see 50,000 miles into space. The factory will still sell the telescope if it is 7,250 more or less than what it says on the box. What is the furthest away that the telescope can see? What is the nearest the telescope can see? Okay, so now to set this up, we have to take x and subtract the goal. In this case, the goal is 50,000, so x minus 50,000. We go ahead and put our we're going to put our absolute values. And we're going to set this equal to the more or less factor, which is 7,250. Now, we can go ahead and split this right away because of the fact that the absolute value is isolated. So x minus 50,000 equals the negative version of it or the positive version of it. Now, what we're going to do is, in both of these, we're going to add 50,000 to both sides. 50,000 cancels here. X is equal to 42,750. On the other side, we're going to still add 50,000. This is going to get us 57,250. So now what this actually means is for the max and the min, the minimum would be 42,750 miles, and the maximum would be 57,250 miles. All right, guys, thank you, and I'll see you tomorrow. Have a good one.